formation of water, a seemingly simple yet profoundly vital molecule, is a captivating journey into the realm of chemistry. At its core, water is composed of two hydrogen atoms, covalently bonded to one oxygen atom, represented by the chemical formula H2O. The intricate dance of electrons and atoms that leads to the creation of water unfolds through a series of interconnected steps, providing insights into the fundamental principles that govern chemical reactions. To embark on this journey, we must first understand the elemental players, hydrogen and oxygen. Hydrogen, the lightest and most abundant element in the universe, is characterized by a single proton in its nucleus and a lone electron orbiting it. Oxygen, a heavier element, boasts 8 electrons arranged in 2 electron shells around its nucleus of 8 protons. It is the outermost electron shell, the valence shell, where the chemistry of water formation takes center stage. The formation of water begins with the dissociation of the diatomic oxygen molecule, O2, into 2 oxygen atoms. This dissociation is often initiated by external factors such as heat, light, or electrical energy. Breaking the oxygen-oxygen bond requires an input of energy to overcome the attractive forces holding the oxygen atoms together. Once the oxygen molecules are split, each oxygen atom becomes highly reactive and seeks stability through the formation of bonds with other atoms. Enter hydrogen, another highly reactive element due to its lone electron. Hydrogen gas, H2, consists of diatomic molecules, with each hydrogen atom sharing a pair of electrons. The inherent reactivity of hydrogen arises from its desire to complete its electron shell, a characteristic that propels it into a dance with oxygen, leading to the formation of water. As the reactive oxygen atoms encounter hydrogen molecules, a captivating molecular interaction unfolds. Each oxygen atom is ready to accept 2 electrons, and hydrogen is poised to contribute its electron pair. The sharing of electrons ensues, resulting in the formation of covalent bonds between oxygen and hydrogen atoms. This process leads to the creation of water molecules, where each oxygen atom forms bonds with 2 hydrogen atoms. This equation illustrates that 2 molecules of hydrogen gas react with 1 molecule of oxygen gas to produce 2 molecules of water. Importantly, the equation adheres to the principle of conservation of matter, affirming that the number of atoms on both sides remains constant. The formation of water is not a passive event, it is a dynamic process that releases energy in the form of heat. The combustion of hydrogen and oxygen is an exothermic reaction, signifying that energy is liberated as new bonds in water are formed. This release of energy is visually apparent in the form of a flame when hydrogen and oxygen gases combust. The heat generated during this reaction underscores the strength of the bonds forged between hydrogen and oxygen atoms in the water molecule. While the combustion of hydrogen and oxygen is a well-known pathway to water formation, it is crucial to acknowledge that water can also be produced through various other chemical reactions. In living organisms, water is frequently a byproduct of metabolic processes. Cellular respiration, a fundamental process for energy production in cells, involves the reaction of organic molecules, such as glucose, with oxygen to yield carbon dioxide, water, and energy. Moreover, the water cycle, a fundamental planetary phenomenon, illustrates the continuous transformation of water between its liquid, gaseous, and solid states. This cyclical journey involves processes such as evaporation, condensation, precipitation, and runoff. The water cycle showcases the adaptability of water, allowing it to exist in various forms and traverse diverse environments. In the grand tapestry of the natural world, the formation of water is intricately interwoven with countless biological, geological, and atmospheric processes. Beyond its role as a life-sustaining substance, water influences climate patterns, shapes landscapes through erosion and deposition, and participates in the delicate dance of biochemical reactions within living organisms. As we delve into the molecular intricacies of water formation, it is imperative to appreciate the broader context of its existence. Water is not merely a chemical compound, it is the elixir of life, an indispensable component for the flourishing of ecosystems, the survival of organisms, and the maintenance of the delicate balance that characterizes our planet. In conclusion, the formation of water is a captivating journey through the intricate world of chemistry, where the elements hydrogen and oxygen engage in a meticulously choreographed dance to give rise to a substance essential for life. From the dissociation of oxygen molecules to the covalent bonding of hydrogen and oxygen atoms, the process is a symphony of molecular interaction.